Good day. This is our first lesson, which is entitled Applicable Electric Materials in the Preparation of Architectural Buildings. Okay, for the learning outcomes for this lecture are: number 1, name common electrical terminologies. Second one is define electrical concepts and materials for designing the system. Now, we will proceed to the overview. These are the topics: conductors and insulators. You will understand wires and cables, wiring and raceway method, wiring devices, and lastly, the electrical instruments and equipments. To proceed to the first topic, which is wires and cables, we will have a short discussion about the major components of electrical building system. We have three major components of the electrical building system. First one is the wiring and raceways. Second one is utilization of equipment. The third one is the power handling equipment. Okay, for this slide, we will discuss about the wiring and raceways, which we have 4 branches: the conductors, the wires, cables, conduiting, raceway, and ducting. Conductors and insulators. Okay, we will define each of these words. The electric conductors are substances or materials used to convey or allow the flow of electric current, while the insulators are substances or materials that resist the flow of the current. Okay, we have the following conductor materials in this left side, and also we have the following materials, which is insulated materials. Now, as conductor, the definition of conductors are materials which allow the free flow of electrons through them. Okay, this is already discussed for the week 1. And they are the substances or materials used to convey or allow the flow of electric current, which is we have 2 different flow of current. We have the conventional current and the original flow of current, or original flow of electrons. Now, we have 3 common conductors in the industry, and this is highly used in the electrical field. Okay, number 1 is the wire, cable, and busbar. Okay, we have this. This picture represents as busbar, which is commonly seen in panel boards and low voltage and high voltage switch gears. Okay, wires are single insulated conductors number 8 AWG, which is American wire gauge or smaller. Okay, this is for the English system. So it is the B&S gauge or Brown and Sharp gauge. So the smallest size of wire permitted is number 14. Okay, if you here in the Philippines, we are using American wire gauge, which is under the English system, and also we are using the SI system, which is converted into mm squared. Okay, for the next slide, we will discuss about the conversion of the American wire gauge to square millimeters. Okay, we have difference. Wires are single insulated conductors, number 8 AWG or smaller, while we will identify the conductor as cable if the single insulated conductors number 6 AWG or larger. Okay, conductor will be called as wire if it is number 8 AWG smaller, while cable is number 6 AWG or larger. While the busbar, these are the large conductor which is not circular. Okay, this is not circular because wire and cables form as circular core, while the busbar is in cross section and usually found only to supply the main switch box, which is panel boards. Okay, for the next slide, okay, this is the table of conversion of the wire system. So take note that the American wire gauge is the US standardized wire gauge system. So since we have history that the Philippines colonized by the American, so that is why we have American wire gauge system in electric wires. While some of the updated Philippine Electrical Code and National Electrical Code using now square millimeters, even also when you are going to the market, some of the boxes of wires are measured by square mm. So since as a general rule, traditional electricians are using AWG, but modern electricians today, modern electrical engineers are using mm squared. So earlier we discussed the conductors number 8, AWG. So let's go to the table. So AWG 8, so the size of the wire is 10 mm squared, which is, so 8, 6, 4, 8, 10, 12, 14, and 16 are cables. Okay, so take note that in AWG number 8, AWG or smaller, but in AWG the corresponding number is going or increasing. So 8, 10, 12, 18, 30. So the highest number of AWG is 30, but it is the smallest size, 0.05. Okay, so while the cables, which is number 6, AWG, so start with 16 mm squared until 500 mm squared. Okay, this will be your guide in buying and designing electrical wires. So please be familiar with the wire conversion. So we have a short explanation. Okay, so since 1857, wire gauge to mm squared made determining a wire's current carrying ratings easier. So until now we are using this. So AWG is determined by first figuring out the radius of wire squared. So this is the formula, times pi. So oftentimes the term circular mil is used. So circular mil is the area of 1 over 1000. And the circular mil is highly used in large cables. Okay, but since we are in building wiring or building electrical, so we are considering building cables only. So we are using mm squared as the highest base size or gauge size of the wire. Such measurements are made on only the wire and not on the wire jacketing or insulation. Okay, so since smaller gauge sizes are more durable and flexible, it is common practice to use them with higher AWG numbers. Okay, take note, higher AWG numbers. So that is why 30, which is the highest number, but in converting into mm squared is just 0.05. So that is why AWG wires are always slightly bigger in diameter than solid wire. Take note that AWG is determined by first figuring out the radius of wire squared times pi. Okay, radius of wire squared times pi. Now, so aside from the size of the cables, what's the difference between wires and cables? So let's consider this next slide. So wires are those electrical conductors 8 mm squared. So we have the guide now, 8 and smaller in sizes. So cables are those which are larger than the wires. So wires and cables are either stranded wire and solid wire. So this is the representation of these two wires. We have standard wire versus solid wire. Now in electrical applications like cable assemblies and wire harnesses, Choosing stranded wire versus solid wire will depend on the job requirements. So the physical differences between the two wires are straightforward enough. So a solid wire consists of a solid metal core, while stranded wires are made of a quantity of thinner wires that are twisted together into an organized bundle. Okay, both stranded and solid wires are used by engineers in a wide variety of cases. In any case, there are advantages and disadvantages of stranded wire versus solid wire that led to selecting one over another for each particular application. There you can see the key factors. So let's discuss about the stranded wire. So stranded wires offer a few acute benefits over solid wire. They are flexible, malleable, and will not split or sever. Because they are bundled, stranded wires are relatively more flexible, intricate, and delicate. They are better suited for indoor use on circuit boards, speaker wires, electronic devices, where bending and twisting are necessary to connect electronic components. For example, an ideal application of stranded wire is in a car door where frequent bending will occur. So that is the best example. Now, the solid wire pros. It is a weather resistant, anti-corrosive, and also a low cost. A solid wire is heavier, made of all weather conditions. It is anti-corrosive, rugged, and can withstand frequent but minimal movement. So an ideal application of solid wire would be carrying power through a building structure. So as this requires a high current, little movement, and long-lasting durability. So let's discuss about the types of electrical wires and cables. So first one is the residential wiring cables. Under residential wiring cables, we have service drop cable, main feeder wires, panel feed wires, non-metallic sheeted wires, single conducted or conductor wire. So let's first discuss the service drop cable. At the left side of the slide, this represents the service drop or service entrance of a residential building. So this is a service drop cable going to the electric pole meter from the distribution, for example, the light. And this is your weatherhead, which is also service cap. You can call it a service cap. Then the meter base. So the cable between the utility pole and the consumer premises or of a building. So the service drop cable is an overhead electrical line from the pole to the service weatherhead of a house. So the service drop cable can be identified as duplex cable, triplex cable, and quadruplex cable. Now the next one is the main feeder wires. So the main feeder and cable wires, you can click this link for more details. So this is a hyperlink. So it will lead you to the original file. The main feeder cables and wires supply the power from the service weatherhead to the building. Okay, this is a larger size of wire. So the cable used for this purpose are 600 volts, THHN, solid or stranded, with a rating of 25% more than the maximum required load. Even though Philippines are using 230 volts, we are using wires that are rated 600 volts. Okay, take note of that. Okay, aside from the main feeder wires, we're going to smaller sizes. So these are the panel feed wires. Okay, the panel feed wires, as you can see on the image, these are the smaller size of wire connected to the circuit breakers. Okay, these circuit breakers are considered as branch circuits. So later on, we will discuss about the branch circuit. Okay, the panel feed wire supply power, power the main distribution junction box. So junction box is the box where devices, wiring devices are connected together, going to the circuit breakers. So it is usually black insulted precision cables with rating of 25% more than maximum load current. Now, so the non-metallic sheeted wires. So you have also non-metallic sheeted wires. So the non-metallic or NM sheeted wires are used for in-house wiring. So it may consist of two or more than two insulated conductors within insulated or bare ground conductors. So as you can see in the picture below that they are sheeted wires, but they already have three or more wires. So we have three wires in a one sheeted wire. Okay. The second one is four stranded wires in a sheeted wire. So let's consider the two wires and sheeted cable. So this type of cables has two separately insulated conductors with a bare conductor. So as you can see, we have a non-metallic outer sheeted, then another insulation, and the phase wires. So yeah, this is the easiest one in terminating wires because in one cable there's already a three or more wires involved, or it contains two wires plus a ground wire. For example, we have two phase wires per ground wires. Okay, these are the best illustration of the non-metallic sheeted cable. While we have a three wires and sheeted cable, this is a large cables that used in the industry. So aside from a non-metallic, we have also a metallic sheeted cable. So this is armored cables. Take note that the metallic sheeted cables are conductors separately insulated with plastic layer. Okay, may plastic layer pa siya from metallic to a plastic layer. Okay, the second one. The first one, metallic, the plastic, insulated, then the conductor. Okay, the metal sheet can be braided or twisted that surrounds individual or conductors, or it could be a solid pipe-like structure. So this is commonly used on underground and also in air installation, but in high voltage requirements. So let's discuss some of the types of metallic sheeted cable. The first one is the AC cable, so armored cable. So from the insulation is also a steel wire braid, or sometimes it's steel wires and steel tape. Okay, they are not used in damp or wet locations as well as underground because this is highly conductor, so it can conduct electricity. So this is a very dangerous to use in underground system. So the steel wire armored is most common type of armored cable used for power transmission. So this is commonly on some of the generation, on some transformer substation. The next one is the metal clad cable. So this commonly you can see it in the mall. Okay, steel or armor, then the phase wires. Okay, the difference between AC and MC cables is that AC cables metallic sheet cannot be used as grounding wire. Take note of that. AC cables metallic sheet cannot be used as grounding wires. Thus, they can be used as direct burial type and in wet locations, but if they have their protective PVC outer sheet. So unlike the AC cable, like this earlier, you cannot use this in the damp or wet location, while the metal clad cable, you can use this as direct burial type or underground or in wet locations. But take note, there's a provision that you must use a protective PVC outer sheet. Now we have single conductor wire. This is common. Okay. everything, everywhere in the market, uh, this is already available in a single conductor wire. So it is the most popular choice for electrical layout inside the home. So it is available in multiple gauges like AWG, color because color represents phases, neutral is the white, the ground is a green, but sometimes the phase is we use red, yellow, and blue, or sometimes red and black. So for neutral, this is just only a white color in the Philippines, but in the ground is we use green wire. So a single solid wire provides better connections, but a single standard wires are easier to route through conduits. So these are the two different pros of solid wire and standard wires. So available in the market, we have THW and THHN insulation. Now, based on the insulation, so let's be familiar with the characteristics of selected insulated conductors for general wiring. So we have, if you are using KHW wire, you can use it in the moisture and heat resistant rubber. So these are the trade name. So earlier I mentioned THN and THW. So the provision for application of these wires, you can use it for dry location, while the THW you can use it dry and wet location. Take note for these two wires, they are thermoplastic heat resistant. So thermoplastic heat resistant, moisture and heat resistant thermoplastic. Okay, this is the common wires that we use in the Philippines. Now for electrical conduit, sometimes it's commonly called in common jargon, pipe or tubo. So a plastic or metal pipe where electrical wires are running is called an electrical conduit. So don't be confused on the conduit and pipe. Okay, they are the same, but the proper term for that is electrical conduit. Let's consider the first type of electrical conduit is electrical metallic tubing or EMT pipe. So electrical metal tubing is one common example for unbending conduit. Take note, this is not for bending, unbending conduit. So it is generally made of galvanized steel. So EMT is typically described as a thin-walled conduit because it is thinner and lightweight compared to RMC. So in the industry, EMT are using it for auxiliary wiring, for electronics wiring, just like for telecommunications, for telephones, and for smoke detector wiring. So furthermore, the standard sizes available for EMT include 1 inch to 1.5 inch only. Okay? Take note for that, the standard sizes available for EMT include 1 inch to 1.5 inch. And it can be used in exposed indoor wiring where EMT is generally used because it often runs in light commercial or residential construction. So take note of that the tubing itself isn't threaded like IMC or RMC. So based on the picture, there is no thread. Okay. The second one is the RMC. As you can see, there's already a thread, unlike the EMT. Okay, rigid metal is considered one of the most costly options for electrical wiring in the market. However, it greatly offers additional strength and durability, which is a huge plus. That is why some of the service entrance and pipe connecting into meter base, we are using RMC or RSC, which is rigid steel conduit. Sometimes it is called rigid metal conduit. So RMC is only available to sell for about 10 to 20 foot lengths or 3 meters. And it must have threads on both ends. So as you can see, there's a thread. The third one is the IMC. So IMC is more likely a lighter weight and thinner version of RMC. Still, there's a thread, but it is a thinner and lightweight other than the RSC. So in some cases, IMC is more common to use in construction because it is much lighter, but sometimes it is used on the under the roof system. Okay, if you need a higher protection of your wires and cables, so we use IMC. The next one is the flexible metallic conduit. Sometimes for the older electricians, older practitioners in electrical, they are using the name as greenfield other than the FMC. So because it derived from the name of the inventor. So moreover, FMC is always a great substitute for many areas that requires close quarters and tighter bends. So we cannot avoid the bends in a structure in a building, so we need to follow the corners, so we are using flexible metallic conduit. Okay. The latter will make it harder to bend regular conduits. Okay, the FMC, rather the RSC, ANT, they are harder to bend regular conduits. So the best option is the flexible metallic conduit. So lights, attic vents, and water heaters are common examples of basic flexible conduit insulations. Next one is the liquid tight flexible metal. So while LFMC or liquid tight flexible metal conduit is a special type of flexible metallic conduit used when necessary sealed fittings and as a plastic coatings. Okay, this metal electric conduit is also used with outdoor equipment like air conditioner units. So if you have an HVAC or a split type aircons, they are using LFMC. So aside from metallic conduits, we have also a non-metallic conduits, and this is commonly called as flexible hose. So sometimes a common color in the market is orange, but we have also red, yellow, blue, which serves as a guide for the phase. Okay, phase wires, because we have also a color for wires which is red, yellow, blue. So ENT is the true name of the flexible hose, electrical and metallic tubing. So ENT can be installed within concrete blocks. Okay, they can be embedded to concrete blocks. Okay, and can be initially covered. Okay, that is what we call can be initially covered with concrete. Okay, moreover, ENT is nicknamed as smurfing tube because of its blue color. If you are using the blue one, so smurfing. Okay, this is the most common conduit of all time. So even though you don't have any background of electrical materials, this is the most common. Okay, PVC or rigid polyvinyl chloride. So it is quite like plastic plumbing pipe and allowed to corrosive environments. This is also applicable for embedded or can be used underground and apply in just like concrete materials. So it is only proven that PVC is really suitable for a quick burial underground and for several other applications like embedded in concrete. And it has many fittings and some of devices just like junction box and utility box on its material. Now, advantages of using PVC. Number one is available in various wall thicknesses. Okay, so since earlier I've already mentioned that it can be used in embedded application. Second one is the commonly less costly. Okay, costly compared to other available options. Third one is extremely lightweight, versatile, and easy to install. And lastly, works perfectly well both in undergrounds and concrete. Take note of that, we have a Philippine Electrical Code, which is we have provision of using PVC. It is not applied or it cannot be used for exposed environment. PVC can be used in these 4 advantages. Wall thicknesses embedded, easy to install if it is inside or indoor system, and for underground and concrete system. So aside from conduit, round conduit, we'll also consider the cable raceway. So cable raceways are common for auxiliary system and also for wires in theaters, or even static wire way system. So cable raceways provide a surface-mounted pathway for wiring that completely encloses the cables and protects them from heat, dust, light, and even moisture. So we cannot avoid wirings that passes through a hallway, common way for a theater, common way for commercial establishment. So in addition to the cable, Articles Chapter 3 of the National Electrical Code contains a sequence of articles pertaining to raceway. So the Article 100 definition of raceway indicates that it is an enclosed channel designated expressly for holding wires. Okay, this is a channel. Okay, different sizes, cables, and bus bars. So when viewing the types of raceways included in the definition, it can be broadly divided into a circular raceways, which is conduit earlier, which is I discussed earlier. That is a circular raceways. And the cable raceways is considered as non-circular raceways, such as wireways. So we have 2 specific types of circular raceway, which is conduit and tubing. And the cable raceway that we discussed in this slide is the tubing. Now the tubing, there are different types of tubing or cable raceways. The number 1 is the latching raceways, and this is used in application if it is yung pahabol ang wiring. Okay, may pahabol na wiring or late wiring or late installation of any devices. So to avoid any disruption of your design, so they are using latching raceways. Okay, it's also known as surface raceways and latching ducts. So the next one is a corner duct and used for cornering. So these are ideas for residential use. So that is why we call corner duct. So it hides external wiring but can be fit into wall corners for a more discreet look. Okay, so aside instead of using round conduit, you can use the corner duct passing through your wall corners. While if the wire are passing through the floor or hallways, you will use the overfloor cable raceways. So it is more common on malls. So these plastic raceways are usually flatter and more low profile to avoid creating an unnecessary tripping hazard. You've likely seen one of these if you've ever been to a conference hall or a concert where wiring is run across flooring that gets a lot of foot traffic. The next one is the exterior wire guards, which is used in the walling. So if you have sometimes telecommunications just like PLDT, cable providers, they are using exterior wire guards. Okay, these cables are used for use outside, so from the exterior world. Then the flexible wire duct, common for computer system. So these cable raceways are versatile wiring enclosure that can be used in both industrial and commercial applications. And we have floor raceways, which is neck recognized. We have 3 types of floor raceways. The underfloor. So here, this is the underfloor where you will guide the PVC conduit from next location to the next location using the concrete raceway. This is what we call underfloor ducts, and it is used for power, telephone, and signal cabling, just to protect the conduit. The next one is the cellular metal floor raceway, the first picture, found usually in office landscaping. Then the precast cellular concrete, also in the third one. So this more common, underfloor ducts and precast cellular. Now, before we end this lecture, let's consider the benefits of cable raceways in architectural design. Okay, so let's integrate the electrical design to architectural design. So that is why the application of cable raceway is highly applicable. So these are the three benefits. Cable raceway are easy to install. Next one is the streamlined cable management. Then you can promote safety. Okay, this is the last slide. Thank you.